Hello everyone, how are you? I'm Ghida Al-Hello, student at Faculty of Engineering. Today we're gonna talk about differences between artificial intelligence AI and regular programming. Algorithms based on AI methods have a different logic than that followed in traditional programming algorithms in terms of the relationship between the input and output of the algorithm and how it works. This information may seem strange to some, but the theoretical foundation of AI have been around for more than 60 years. But it was relatively late to become widely used as it is today. On the other hand, traditional software has developed significantly since the construction of the first computer until today. So, why did AI need to spread widely until today and accompany us in our daily lives? In this article, we will clarify the answer to this question and compare AI with traditional programming. Number 1. How do we write a traditional program? If you want to program an algorithm to solve a problem, the method that we will follow is according to the follow image. Here, the main task of the programmer is to write the algorithm, so what we get the desired output, and the work of the algorithm here is to continuously process the input data in order to obtain the desired output. As an example, the input will be a map and the desired output is the shortest path between 2 points on this map. If we take the example of predicting a property price, a traditional algorithm will need a number of data to process and estimate the property price based on it, such as the property area, number of rooms, and location. When entering this data into the processing algorithm, it can be compared with a reference table or information bank that includes information about property price according to their area, number of rooms, and location. And what our algorithm will do in this case to compare the information and the income and the information bank and choose the price or calculate it based on that. It is important to note an important point here. The previous program is fixed, and its ability to determine the property price is limited by the way the algorithm processes the data. If we want to improve the accuracy of algorithm, we must rewrite the program, translate it into machine language, generate the executable file, and test it again. This is what happens, for example, when updating applications and programs on smartphones and personal computers. Number 2. How to build an AI model. Given the widespread use of AI applications based on machine learning methods, we will limit our example in this video to an application that relies on machine learning model to solve a specific problem. Here, the developer needs an input and output and a learning algorithm. Based on this data, we will option a model that can be used later. The difference with applications based on traditional programming algorithms is that applications based on machine learning models initially need a training process before they are able to perform the task required of them. During the training or learning process, the required data to be processed is entered in addition to the expected output, and the goal is to teach the model how to process the data in order to reach the desired output. In other words, we tell the machine learning model during the training process about the goal we aspire to achieve, and by repeating the training process, the model improves its performance by continuously comparing the input data with the desired output. It should be noted here that the previous example is for supervised or direct machine learning models. Supervised learning, and there is another type of models that are unsupervised learning, meaning that the training process itself includes teaching the model how to recognize the output that should be reached, and then improving the accuracy of the output through successive training operation. For example, using machine learning, we can build a model that can predict the price of a property. First, we will need data about the properties that have been sold, so the income will be data about the properties, area, number of rooms, and location. At the same time, we will need a tag that's proportional to the income data, which is expected output, such as saying that for a property with an area of 100 square meters and a sinking number of 3 and in a central location within the city, the price will be high, while a property with the same area and number of rooms but in location far from the city center will have a low price. When we enter data into the model by adding a tag to each data set, we help the model know how to make a decision about determine the price of the property. Finally, after completing the training, the model will be able to estimate real estate price on its own, but only on income data within the need for additional output data or tags. Compared to programs based on traditional algorithms, we will find that the program based on the machine learning model has the ability to improve its accuracy without the need to update it and modify its source code. On the other hand, machine learning programs and applications learn how to predict the output and how to improve their accuracy, while traditional programs and applications are limited to the algorithms originally written by programmers. In this way, the difference between traditional programming methods and the programming methods based on AI models can be summarized as follows. In the case of traditional programming, we aim to know the output, while in programming in the field of AI, we aim to build the algorithm itself through the training and education process that the AI model receives. Point number 3. Will traditional programming become extinct? No. It is worth noting that software based on AI models does not represent an alternative to traditional programming, but rather a complement to it. For example, if we want to program an application to predict the price of property, we can use the model though in the previous paragraph to option the results, while the user interface will be programmed in traditional way. This is not limited to traditional programming, and algorithms will be present in the future, not only through user interfaces. Point number 4. Where is traditional programming used? It is preferable to use traditional programming in the following cases. Number 1. The speed of results is not very important. Number 2. The accuracy of the result is very important. 3. The ability to track the processes performed and interpret the result is very important. And finally, in highly regulated areas. Point number 5. Where is AI used? It is preferable to use AI in following cases. Number 1. Speed of results is important. Number 2. Accuracy of results is less important. 3. Less importance of interpreting results. 4. In less regulated fields. Point number 6. Advantages and disadvantages of traditional programming. As mentioned earlier, it is preferable to use traditional programming when there is a need for better tracking of results, as it provides greater transparency and every step and every result that the program will produce can be explained. This is the preferred method in highly regulated fields and where aspects such as the degree of protection play top properties. In such files, only specific and deterministic information can be dealt with, because a simple probabilistic error may lead to the failure of the entire system. And what AI models do is calculate the likelihood, which is a variable percentage and not a fixed, specific and deterministic value. However, AI has already begun and entered these files, but on a limited scale due to the transparency and determinism of traditional programming. It places a great burden on the programmer, as he must include all the possibilities that the program may encounter during use. Neglecting just one possibility can lead to disaster results. Point number 7. Advantages and disadvantages of artificial intelligence (AI). When writing a traditional program, it is inevitable to define all input regardless their number of type. This can be dealt with when the number of inputs is limited, 1, 100, or even 1000. For example, but what if we need a million or billion inputs? In this case, it is difficult to deal with this large number of inputs manually, and here we can use a machine learning model that can handle the large number of inputs. In addition to the flexibility of AI and its ability to adapt to change without the need to define this change in advance, as the case with traditional software. On the other hand, the huge amount of data used to teach an intelligent model makes the processes of tracking and interpreting the results very difficult or almost impossible. One of the prevailing concerns today is that AI consumes large amounts of energy during the learning and training processing, as this learning process requires a large number of computational operations that are usually performed on graphics processing units (GPUs). It is difficult to make a direct comparison between AI and traditional algorithms in terms of energy consumption, but there is a lot of research that delves into how to make the learning process more efficient. In addition, there are tools that estimate the carbon dioxide emission resulting from the learning processes. Point number 8. Why now? As we mentioned before, that the foundation of artificial intelligence (AI) have been around for more than 60 years. So why did it take us until this day to see its practical applications in our daily lives? While traditional algorithms were and still are widely used, the question can be answered by returning to how an AI model is developed. In order to teach the model, we need a large amount of data to be the basis of the learning processes. The increase in the amount of data is directly proportional to the quality and accuracy of the resulting model. Therefore, it was difficult to teach intelligence models in the past due to the scarcity of data collected at that time, while traditional algorithms do not need the huge amount of data that artificial intelligence AI needs. And thank you.